Imagine stepping outside at noon and feeling the desert try to cook you alive. The ground burns through your sandals. The wind is hot enough to feel like someone opened an oven door directly into your face. There is almost no shade, no electric fan, no refrigerator, no freezer, no air conditioner, and yet somewhere nearby, underneath a giant mud brick dome, there is ice. Real ice. Not a tiny cube floating sadly in a drink. Huge slabs of frozen water. Enough to chill food, preserve meat, cool drinks, make desserts, and survive months of brutal Persian summer. And the strangest part? Nobody plugged anything in. No electricity. No compressor. No modern refrigeration. Just mud, wind, water, geometry, and some very clever people who understood the desert better than most of us understand our own refrigerator. Today you are not visiting ancient Persia. You are living there. And before this day is over, you are going to help manufacture ice in the middle of the desert. It is sometime in ancient Persia. You wake before sunrise because, frankly, waking after sunrise is a terrible idea. During the day, the heat can become punishing. But right now, in the darkness just before dawn, the desert is surprisingly cold. You pull your robe tighter. That is the first thing you need to understand. A desert is not simply hot, it is extreme. During the day, sunlight heats the land brutally. But at night, especially beneath clear skies, that heat escapes rapidly. Without thick clouds to trap warmth near the ground, nighttime temperatures can drop dramatically. And Persian engineers noticed. Of course they noticed. If your survival depends on understanding heat, water, and weather, you become very interested in what the temperature is doing at 3 in the morning. You walk through the settlement while most people are still asleep. Ahead of you rises something that looks almost impossible. A giant pointed dome made from earth. From far away, it resembles an enormous clay beehive. The structure may rise many meters above the ground. Its walls are thick. Its base is broad. Its surface is rough, sun-baked, and almost the same color as the desert itself. This is a Yakhchal. The name essentially means ice pit, which sounds simple. It is not simple. It is one of the most impressive pieces of passive cooling engineering in the ancient world, and you are about to climb inside. The entrance is small compared with the enormous dome above you. That is deliberate. Large openings let heat inside. Small openings do not. You duck through the doorway. Immediately the temperature feels different. The sunlight disappears. The noise of the outside world softens. And then you see the real scale of the structure. The dome above ground is only part of it. Below you is a massive underground chamber. A deep storage pit descends into the earth. The deeper you go, the cooler the air becomes. This is not magic. Earth itself acts as insulation. While the desert surface may be scorched by sunlight, underground temperatures fluctuate much less. The builders are using the ground as a natural thermal battery. A very large, very dirty-looking refrigerator, except calling it dirty is unfair. The interior surfaces have been carefully constructed using a special water-resistant mortar. Traditional Persian builders used materials that could include clay, sand, lime, ash, and other ingredients blended into a strong insulating mixture. Some formulations are known as sarouj. Sarouj is extremely useful here. Ordinary mud walls exposed to moisture can slowly weaken. An ice storage chamber needs walls that resist water. After all, ice has an unfortunate habit of turning into water. So the builders coat and construct the Yakhchal carefully. The walls are thick enough that heat from outside struggles to penetrate. In some surviving examples, those walls become extremely massive near the base. You place your hand against one. It feels cool. Outside, the sun has not even risen yet. Inside, yesterday's cold is still hiding in the structure. That is exactly the point. But there is a problem. A giant insulated hole can store ice. It cannot automatically create it. And hauling ice hundreds of kilometers from snowy mountains would be extremely difficult. So where does the ice come from? You step back outside. Someone points toward a long, shallow pool. At first glance, it is unimpressive. It is basically a rectangular basin, very shallow, very wide. Next to it stands an enormous wall. The wall may run east to west, creating a deep strip of shadow. This is where things become brilliant. During cold winter nights, water is poured into the shallow basin. Not deep water, just a thin layer. Why? Because shallow water loses heat faster than a deep pool. And the wall protects the basin from direct sunlight during critical periods. At night, the dry desert air and clear sky allow the water to radiate heat upward. The basin cools. The water gets colder and colder. And if conditions are right, a thin sheet of ice begins forming across the surface. You crouch beside the basin. The ice is fragile. It cracks easily. Nobody expects to create a 1-meter thick block overnight. Instead, the process happens gradually, night after night. A thin layer freezes. Workers break it apart. The ice is carried toward the Yakhchal. Another thin layer freezes later, then another, then another. Eventually, the underground chamber begins filling. You suddenly realize something important. The Persians are not fighting the desert. They are making the desert work for them. The clear sky helps cool the water. The dry air helps evaporation. The cold winter nights produce freezing conditions. The earth insulates the storage chamber. The thick mud brick walls resist outside heat. Every environmental problem has been turned into part of the machine. And the machine has almost no moving parts. By sunrise, the workers are moving quickly. Ice does not appreciate long conversations in daylight. Blocks and broken sheets are transported into the storage pit. Layers of ice may be separated using insulating materials such as straw. The goal is not to create something beautiful. The goal is to create a giant thermal mass. Imagine filling an underground chamber with enormous quantities of ice. Now imagine surrounding that ice with thick insulated walls. Then imagine placing the chamber partly below ground. Even when summer arrives, the entire frozen mass does not instantly disappear. Yes, some of it melts. That is unavoidable. But clever drainage channels can carry meltwater away from the stored ice, and some systems may allow very cold water to collect in lower sections. Keeping meltwater away matters. If the ice sits surrounded by warmer water, melting accelerates. Drainage slows the process. Again, nothing dramatic. Just dozens of small engineering decisions working together, which is usually what good engineering looks like. Not one miraculous trick, 100 boring tricks cooperating extremely well. A few months pass. Now it is summer. And summer in this region is not gentle. The sun climbs. The streets brighten until everything seems bleached. Animals search for shade. People reduce unnecessary movement during the hottest hours. You walk toward the Yakhchal again. The giant dome appears almost absurd beneath the blazing sky. You remember carrying ice inside during winter. Surely it must all be gone. You descend. The temperature drops. And there it is. Ice, still there. Months later, you stare at it. This is the point where a modern visitor might start saying things like, "How is that possible?" But nobody around you finds it supernatural. They built it. They know exactly how it works. The Yakhchal is not merely a storage shed. Its shape matters. The tall conical dome helps control internal temperature and airflow. Hot air naturally rises. The thick lower walls provide insulation. The internal geometry allows warm air to move away from the deepest, coldest area. Some Yakhchals may also work alongside windcatchers, another ingenious feature of Persian architecture. Windcatchers are towers designed to capture moving air and direct it into buildings. Depending on their design, they can help ventilate interiors and create cooling effects. And when air passes over water, evaporation can lower temperature even further. This means the ancient Persian cooling system can involve several technologies working together: shade, nighttime freezing, radiative cooling, evaporation, underground insulation, thermal mass, airflow, and careful architecture. No electricity required. Now somebody hands you a bowl. Inside is something cold, very cold, possibly a chilled dessert. Ancient Persia developed traditions of frozen or semi-frozen sweets, eventually contributing to famous Persian desserts such as faluda, a chilled mixture traditionally associated with thin starch noodles and sweetened flavorings. The exact historical forms changed across centuries, but the basic idea is wonderful. Imagine surviving a desert afternoon thousands of years ago, and someone brings you a frozen dessert. We often picture ancient people as constantly suffering, walking through dust, eating dry bread, getting attacked by mysterious infections. And yes, there was plenty of suffering, but humans have always been extremely motivated by two things: survival and snacks. If you give humans enough time, someone will invent dessert, even in the desert. But the Yakhchal is useful for far more than luxury. Cold storage can preserve food. That matters enormously in a world without refrigerators. Meat spoils. Dairy products spoil. Fruit spoils. Prepared foods spoil. And when food spoils, you cannot simply drive to a supermarket. Food preservation affects survival. Ice and cool underground storage can extend the usable life of valuable supplies. Cold water also becomes extremely desirable during hot months. So a functioning Yakhchal is not merely impressive architecture, it is infrastructure. Think about the modern refrigerator in your kitchen. You probably barely notice it. It quietly keeps food cold every day. If it stops working, suddenly it becomes the most important machine in your house. Ancient communities understood the same problem. They just solved it using buildings instead of appliances. The sun begins lowering toward the horizon. You walk around the outside of the Yakhchal. Now that you understand it, the strange shape makes more sense. Those thick walls are not primitive. They are calculated. The dome is not decorative. It is functional. The underground pit is not just a hole. It is thermal engineering. And the enormous shadow wall beside the freezing basin, That may be one of the most underrated parts of the entire system. Without shade, morning sunlight would begin warming the water too quickly. By controlling when sunlight reaches the basin, the builders extend the period during which freezing can happen. They are manipulating microclimates. A few meters can mean the difference between water staying liquid and water becoming ice. There is something almost modern about it. Not modern in materials, modern in thinking. Observe the environment. Measure what naturally happens. Design around it. Use passive systems whenever possible. Reduce energy demand. Store thermal energy. Protect the stored energy with insulation. This is exactly the kind of thinking architects still use today. Only the ancient Persians were doing it with mud brick. And now we need to address one misunderstanding. You sometimes hear the story told like this. Ancient Persians made ice in blazing summer heat. That sounds incredible. It also misses the real brilliance. In many cases, the ice was produced during colder winter periods and then stored for summer. The genius was not necessarily making water freeze while the daytime desert temperature was scorching. The genius was understanding seasonal temperature changes well enough to create ice when nature allowed it, and then preserving that ice long after the cold weather disappeared. That is actually more impressive. Because storage is difficult. Making ice on a freezing night is one challenge. Keeping it frozen while the world outside turns into an oven is another. The Yakhchal does both. Night arrives. The desert cools quickly. You stand beside the shallow freezing basin again. Workers begin preparing another layer of water. The sky is clear. Stars appear. The giant wall blocks heat and light from one side. The water sits exposed beneath the night sky. There is something strange about watching it. Nothing moves. No machine shakes. No engine runs. No gears turn. No one pulls a lever marked ice. The water simply loses heat, slowly, quietly. And the entire structure depends on people knowing something that would eventually be described with sophisticated physics. Every warm object emits thermal radiation. Under a clear, dry sky, surfaces can radiate heat toward the much colder upper atmosphere and sky. In favorable conditions, a shallow pool can cool significantly. Add cold ambient air, add evaporation, add shade. And freezing becomes possible even when the average daytime climate seems far too warm for ice production. The Persians did not need modern equations to exploit the effect. They needed observation, generations of it. Someone noticed water freezing under certain conditions. Someone else noticed that shallow water froze faster. Someone realized a wall could protect the basin. Someone discovered that storing the ice underground slowed melting. Someone improved the mortar. Someone changed the dome. And over centuries, practical knowledge accumulated. Technology often develops this way, not through a single heroic inventor shouting, "Eureka!" but through hundreds of people quietly making things slightly better. You look up at the Yakhchal. Tomorrow someone might store food inside it. Months from now, someone might drink chilled water from ice created tonight. A child might taste something frozen while the summer sun burns outside. A merchant might preserve valuable goods. A wealthy household might enjoy cold treats. A community might depend on the structure during extreme heat. And almost none of those people will ever think about radiation physics. They do not need to. The building does the physics for them. That may be the most impressive thing about the Yakhchal. It turns knowledge into architecture. Once the structure exists, the walls remember what the builders learned. The depth of the pit remembers. The angle of the shade wall remembers. The thickness of the insulation remembers. The shape of the dome remembers. Every brick contains a decision. And Persia did not develop clever cooling technology in isolation. Across the region, engineers also created qanats, underground channels that transported water over long distances while reducing evaporation. Imagine digging gently sloping tunnels through dry land so groundwater can travel toward farms and settlements. Then combine that with windcatchers. Combine windcatchers with underground spaces. Combine underground spaces with water. Combine all of that with ice storage. Suddenly, ancient Persian cities begin looking less like people helplessly surviving a hostile landscape, and more like communities actively engineering their environment. They could cool rooms, move water, store food, produce and preserve ice, all without electricity. The desert forced efficiency. You cannot waste water easily when water is scarce. You cannot ignore heat when heat dominates daily life. So architecture becomes survival technology. Eventually, the industrial age changes everything. Mechanical refrigeration becomes possible. Electric refrigerators spread. Ice factories appear. Modern cooling becomes cheap, reliable, and convenient. You no longer need a building the size of a small tower to keep your drink cold, which is probably good news for apartment kitchens. But the Yakhchals remain. Some survive into the modern era. Weathered, cracked, partially restored. Still standing beneath the Iranian sun. And when you see one today, it may be tempting to call it primitive because it is made from earth. That would be a mistake. Primitive technology does not casually preserve ice in desert climates for months. This is sophisticated environmental engineering made from simple materials. There is a difference. So tomorrow morning, when you open your refrigerator and complain that your drink is not cold enough, remember the Persian worker waking before sunrise. Remember the shallow freezing pool. Remember the enormous shade wall. Remember the ice being broken into slabs. Remember the underground chamber. Remember layers of insulation. Remember the drainage channels carrying meltwater away. Remember the towering mud brick dome holding back the heat. And remember that more than 1,000 years before anyone could buy a freezer, people were already finding ways to eat cold food beneath a desert sun. Not because they had advanced machinery, but because they understood something just as powerful: how to observe nature carefully and convince nature to do most of the work. The ancient Persians did not defeat the desert. They negotiated with it. They borrowed cold from winter, protected it underground, saved it for summer, and built one of history's most extraordinary refrigerators out of mud. They are about a piece of ice surviving in the desert. Thanks for watching, and I'll see you in the next story.